We're going to continue working in lesson 2.1 on functions, and we're going to see if we can analyze several different things about a graph. Number 15 says to use the graph to determine the domain, the range, the x-intercepts if there are any, the y-intercepts if any, and the missing function values indicated by the questions below. So this is the last part. All right, the first part, domain. I'm going to remind you that domain is the set of x's for which the function is defined. Now this function, although it's quite obvious that it is heading down, when we're talking about domain and we're talking about x's, we're not concerned about up or down. We're concerned about right to left or left to right. So in an x direction, although this is going down, it is continuing to go to the left. And on the right side, although it's continuing to go down, it's continuing to go to the right. This way out here is negative infinity, and way out here is positive infinity. There is no break, there's no gap in between, so the domain in words would be all reals. Everything is in the domain, but in interval notation has blank comma blank where it is the smallest value and the largest value. So the smallest value is negative infinity, and infinity's in your toolbar, comma, positive infinity. Infinity always gets parentheses. Parentheses mean that it does not actually stop at that value. It does not contain it. You can never contain infinity, so it is negative infinity to positive infinity. And anytime you want to talk about all the real numbers, smallest negative infinity, largest positive infinity. All right, now I'm going to talk about the range. Remember that the range is the set of y's. So now I'm talking about up and down. It seems to go down forever toward negative infinity, but it does not go up forever. It seems to have a topmost point. The topmost point is up here, and that y value is 4. So if I were to draw a picture of the range, it would be like this. That's what it would look like. Now, if I'm going to talk about that in interval notation, I have to be blank comma blank. Well, what's the smallest? Well, negative infinity is the smallest. What's the largest? Even though I've drawn this arrow going this way, the largest value is 4. You can never contain negative infinity, but you can, and it does contain 4. So I use the square bracket instead. So my range is from negative infinity to 4 with a closed bracket. Parentheses, brackets. The brackets are, I think, above the P and the Q on the keyboard. If you were going to say this in inequality notation, you would say y is less than or equal to 4. So I'm just giving you some variety of ways to say it, but this particular question, and I'm so sorry, I think I left these off or they disappeared. I think I left them off. Has to be in interval notation. All right, so if I move on and I look for other things, x-intercepts. Now x-intercepts are where the graph crosses the x-axis. So this is an x-intercept and this is an x-intercept. This is the point 3, 0, and this is the point -1, 0. An x-intercept always has a y value of 0, because if you're on the x-axis, your y value is 0. So x-intercepts, use a comma to separate as needed. Because of the way this question is asked, it just wants the intercepts, and it says type as an integer. It does not say as an ordered pair. So what are the x values? Well, one of them is -1 and one of them is +3. That's not an ordered pair. That's a list with a comma separating them. It did not ask for them as ordered pairs. If it had, it would have been -1, 0, comma, 3, 0. But all it wanted were the x values. Part D, it wants to know about a y-intercept. Now that means where it crosses the y-axis. Now this is the point where it crosses the y-axis, and that is the point 0, 3. When you are talking about a y-intercept, the x-coordinate will be 0. So I'm ready, if they want it, to put the ordered pair 0, 3, but it just wants it as an integer, so it only wants the y coordinate of 3, whereas this one only wanted x coordinates. All right, so that was choice A. The last one says f of -2 is. Well, remember, that's really telling me x is -2, find the y that goes with it. The next one says x is +2, find the y that goes with it. So going back to the graph, when x is 2, the y that goes with it is right here, and this is the point 2, 3, so the y, and I think I did the positive one first, I'm sorry, I just did this one. If I look at this one, when x is -2, and I go down to the graph, see if I can tell, I believe this is my answer right here, which is the point -2, -5. So it wants the y value of -5. So remember what this notation means. F of -2 equals, that means when x is -2, find the function's value. The function's value is the y value, it's -5. All right, let's do that again with another graph. Oops, I'm just hopping around here. Wait, slow down. There it is. Number 16. It asks the same questions. All right, looking at this graph, let me enlarge it a little bit. The domain. Remember, the domain actually is left to right. The leftmost x value appears to be -3. The rightmost, I hope I said x, the leftmost x value is -3. The rightmost x value is 0. It does not contain this one because there's an open hole. So I'll put a parenthesis. It does contain this one, so I'll put a bracket. So my domain is from -3 to 0. That's x's left to right. Doesn't contain the -3 because of the hole, but it does contain the 0. So remember to look at your x's. All right, I'm going to erase that. Now the range. Well, I'm getting a few. All right, the range is bottom, top, always smallest to largest. The bottommost y value is -1. The topmost y value is 8. It contains the y value of -1, but it does not contain the y value of 8 because there is a hole there. So, well, this was interesting. -3, 0, bracket, and bracket, -1, 8. So, domain, left to right, range, bottom to top. If it includes the value, put a bracket. If it does not include the value, put a parentheses. All right, x-intercepts, and it just wants the integers again, not the points. This is crossing the x-axis right here where x is -1. Y-intercept, it is crossing the y-axis right here, and y is -1. It wants me to find f of -2, and that means when x is -2, find the function value, which is the y value. So let's look for when x is -2. X is -2 here, and if I go up, I hit the graph here, and if I can read that correctly, that y-intercept, not y-intercept, I'm sorry, it's kind of hard to see. How about I see if I can stretch it? All right, I can see it better. There's the point. When x is -2, the y value at that point is 4. You can enlarge your graphs. I'm sorry, I hope this isn't making you dizzy. I don't know why it's jumping around so much. All right. All right, I actually had to pause the graph to be able to get it in the right place. And so when x is -2, the y value is 4. All right, the last one. Now, we're really going to have to think about this. This will be my last question, but my first question is to find the domain. Now, this is not a continuous graph. This is a graph that is hopping from point to point. So its domain is the set of x values. And I believe that the x values are, I'm going to say them as I point at them, -5, -3, 0, 1, and 5. So what I'm going to do for the domain is list those. It is -5, -3, 0, 1, and 5. It's a good thing it didn't ask for those in an interval because you could not do them in an interval. The range is the set of y values, so the y coordinates of all the points, and all of these have the same y value of 2. X-intercept, this time there's none. This function does not ever touch the x-axis. Y-intercept, here's the y-intercept, and the y value of that point is 2. Now it asks me to do something a little different. It says find f of -5, find f of 1, and add them together. So I want the y coordinate that goes first with -5. So when x is -5, the y coordinate is 2. When x is 1, The y coordinate is 2. Add those together, and that is 4. All right, 2 more questions. Number 18. It's a little bit of an application problem, but not extremely algebraic. What I mean is we're not going to have a lot of algebra skills to do this, but you do need to know something about cost. A cost function, and I did say it was a function, a cost function, c of x, where x is the number of items. In this little story, it's going to be bicycles. It is a variable cost plus a fixed cost. So it is the variable cost plus fixed cost. Okay, now variable means it varies. It varies depending on how many of these items you actually produce. All right, let's go up and read this. It says a company that manufactures bicycles has a fixed cost of $90,000. It costs $200 to produce each bicycle. The total cost for the company is the sum of the fixed cost and the variable cost. Write the total cost C as a function of the number of bicycles produced, and then we'll do something else. So I'm going to write it down here. Cost as a function of X, which is the number of bicycles, is variable plus fixed. The variable is $200 for each bicycle. It is called variable because if they make one bicycle, that part of the cost is $200. If they make 2 bicycles, that is $400. If they make 10 bicycles, that part is $2,000. So it varies based on how many. The fixed cost is simply given as $90,000. Now this is like a formula. Okay, so they're going to want us to type this in here. We'll have 200x plus 90,000. Now we're going to interpret it. C of 100 equals, all right, C of 100 equals 200 times the 100 that they just gave me plus 90,000. So I can go to my calculator. Okay. Whoops. And type in 200 times, I'll do parentheses for that, 100 bicycles plus the fixed cost of 90,000. Enter, and I get $110,000. Let me double check that. Yes. All right, so this cost, either one of whichever one I pick, this is my cost, but it says it costs $100 to produce some bicycles. No, it cost $110,000 to produce 100 bicycles. That's what that is saying. So this is your y value and 100 is your x value. All right, we're going to conclude this lesson with something that we will probably see again, and if you go on to higher math you will see it, but if you don't, it's kind of a limited topic in college algebra. It says if f of x is 7x plus 5, find this very weird looking expression. This weird looking expression is called the difference quotient. They call it that because there is a difference, subtraction, and there is a quotient. In order to do this for a function, we start out with the function. F of x is equal to 7x plus 5. Looking up here, I need to start step number 1, f of a. Well, that just means put an a where the x was. That's 7a plus 5. Step number 2, I need f of a plus h. Now that's kind of weird. It says put a plus h in the place of x. So it's 7 times a plus h, close, plus 5. Now honestly, I probably, if I was trying to do this left to right and then down, I probably, doesn't make any difference, but I probably should have done that as step number 1 and that as step number 2. Let me finish this one. Distributive property, that's 7a plus 7h plus 5. Now I know that right now you don't really know why you're doing this unless you've had a pre-calculus class before. So I'm looking at this. I'm going to from now on call this the first part and this the second part, and the third part is going to be to subtract them. And it says f of a plus h minus f of a. All right, that will be 7a plus 7h plus 5, that's f of a plus h, minus, parentheses, 7a plus 5. Use your parentheses because we studied this earlier in the course. There we go. I'm going to change that, change. That gives me 7a plus 7h plus 5 minus 7a minus 5. If you've done it correctly, some of the terms will cancel out. Positive 7a and negative 7a, positive 5 and negative 5, and you are left with 7h. The answer to part 3 will always have just a term with h. Step number 4, remember I did 1 and 2, then I subtracted for 3, so now I'm going to take that answer, f of a plus h minus f of a, and I'm going to divide it by h. In other words, I'm going to take 7h, which is what the top is, it's what I just found, divide it by h, those divide out, and you get 7. Now, you're probably going to be required to show the steps, but this number is, if it's a number, plain number, then it is actually the slope. And if you look back up here at the original, f of x is equal to 7x plus 5, y equals 7x plus 5, y equals mx plus b. Isn't that the slope? Now, this is kind of a weird little method, and I'm sure that you're thinking it was just a lot of extra step when all I had to do was look up here and see 7. This is part of a big definition in calculus to find the slope or the rate of change. So it has a lot of future value in higher mathematics. Let's look at this one. We are given f of x is 2x plus 5. Now I'm going to find the value of the difference quotient, and I hope that you know it's going to turn out to be 2, but we're going to do it in steps. Number 1, find f of a plus h. Okay, that's 2. In the place of x, I will put a plus h plus 5. That's 2a plus 2h plus 5. Pause. Step 2. Find f of just a. Well, that's even easier. That's 2 times a plus 5, which is 2a plus 5. Step 3 is to subtract them. Use parentheses. It is f of a plus h minus f of a. So it is, open parentheses, 2a plus 2h plus 5 minus, open parentheses, 2a plus 5. Using my red pen to make my changes. Change, change, change. I have 2a plus 2h plus 5 minus 2a minus 5. Let's see what cancels out. The 2a's, the 5 and the negative 5, and I'm left with 2h. My step number 4 is to take f of a plus h minus f of a and divide it by h. That's 2h over h. Cancels out. We got 2. And I know that you might be thinking it sure would have been easier if they had just said, what's the slope of this linear function? And you would have said, well, it's 2, because it's in the position of the slope. But this process helps when you're dealing with a quadratic function, higher degreed functions where you can't look at it and find a number. Anyway, lots of information about functions. Please work on the exercises.